Alrighty, so when we're solving a differential equation for either a particular solution or a general solution, remember the general solution is the one that has a C in it. The particular is the one that has no C in it. We use these same steps we've been using since yesterday. Okay? Everything with a left, move to the right, or to the left. Everything with a Y, move to the left. Everything with an X, move to the right. If you have constants, you can keep them to the right side. Integrate both sides, add a plus C to the X side, the right side. And then either solve for Y, plug in the point, or plug in the point, solve for Y. You can do 3 and 4 interchangeable. You can do either one. Okay, number 6. Okay, so everything with a Y we want on the left. Everything with an X we want on the right. Okay, so first thing, like we've always done, is multiply both sides by dx. Okay. Then how do we get the y stuff to the left? All right. Divide both sides. So we end up with 1 over 2y minus 1 squared dy equals x squared dx. Everything with a y is to the left of the equal sign. Everything with an x is to the right. Step 1 is done. Step 2 said integrate. Well, one side's pretty easy. This side, the right side, is just going to be 1/3 x to the third plus c, right? How do we integrate the y side? What are we going to do to integrate the y side?
U substitution.
We're going to have to use u substitution for the y side because it's the only way we can do it. Okay? Even if you multiply it out, even if you multiply 2y minus 1 times 2y minus 1, you would still have to do u substitution. There's no way around that. Okay? So to do u substitution, I'm going to do it over here. So u is going to be the stuff on the inside, just like we did last semester. We did our last chapter. We did a whole chapter on this. So this part is not new to you guys. You guys have done that before. Divide by 1/2. Divide by 1. You get 2. 1/2 du equals dy. Let me put a little note here. Okay. So we get 1 over u squared dy. Oops, and then I got to put in dy. dy gets a 1/2 and then a du. Okay. So how do we antiderivative or integrate this guy? What do we have to do first? Review from last chapter. So we're going to change this to u to the -2 and then use the power rule. Power rule says add 1 and divide by that new power. So divide by -1, which is the same thing as multiplying by -1. So you get -1/2 u to the -1, which is the same thing as -1 over 2 plus, no, we don't need a plus c for this guy. Okay, so we're going to go put that back. Okay. So you could either solve for y now and then plug in the points, or solve for y, plug in the points now and solve for y. It's up to you. If we plug in the points now, we got x is 0, y is 2. So everywhere you see an x, plug in a 0. Everywhere you see an x, plug in a 0. Everywhere you see a y, plug in a 2.
Does the square, are we supposed to have a square next to the 2y minus 1 in our?
Yeah, also the integration it shouldn't be a square.
Because we took,
Negative 2 plus 1. So.
yeah.
Shouldn't be a square. This guy right here you're talking about?
Yeah.
We got that from doing the antiderivative, right? Right there.
It should be negative, so it's negative 1.
Oh, I see what you're saying. I see what you're saying. Okay. Okay. Solve for C. So 2, let me open this up a little bit. 2 times 4 minus 1 equals, this is just going to be 0. Negative 1 over 2 times 3 equals C. Negative 1/6 equals C. Okay. So now we're going to go plug in our C. So we get negative 1 over 2, minus 1/6. Calculus, well, we stopped doing calculus a while ago. Now you're going to need algebra skills. A really good Math 1 student can do this. If a really good Math 1 student can do this, you guys should be okay with this. Okay? All we're doing is isolating, getting the y by itself. Okay? So a lot of times, this is where I see mistakes. And I'm like, guys, this is not calculus. This is stuff you guys have been doing since probably algebra, probably 8th grade. This is the stuff where we're just getting y by itself. Okay? We got to get y by itself. So the first thing I would do, there's many ways to do this. There's many, many ways to do this. First thing I would do is separate this guy here because it's kind of, there's, actually I don't need the parentheses once I do that. Okay? Divide both sides by negative 1/2, which is the same thing as multiplying by negative 2. So if I multiply by negative 2, I get negative 2/3 x cubed minus, or sorry, plus 1/3. What do I do? How do I get the 2y minus 1? Because I want to get that on top in the numerator. I can't solve it if it's in the denominator. What can I do here?
Is one way of doing this, but I don't know if it'll be correct. You can rewrite it as 2y minus 1 to the negative 1 power, but then again, I don't think that would work.
Yeah, that won't help us because then it's not. So if I want to get something on top, I multiply by it. So I'm going to multiply both sides by 2y. So now the y moves to the other side. And I just get a 1 over here. So I get 2y minus 1 times negative 2/3 x to the third power plus 1/3. I want to solve for y. That's what I want to do. So I'm not going to multiply. What I'm going to do is I'm going to divide now. I'm going to divide both sides. So I get 1 over negative 2/3 x to the third plus 1/3 equals 2y minus 1. Okay? Add 1. I'm going a little fast because I don't want you guys to keep looking up here. I want you guys to think for yourselves. So you guys know how to solve this. Don't do this up, down, up, down. Don't do that, okay? Because then you're going to lose your spot. You guys know what to do. You're solving for y, right? You guys, this is not anything new, okay? Trust your instincts. You guys know how to solve for a variable. He's been doing it for a long time, okay? It's the same thing you guys would do in Math 1 back in 8th grade, okay? Last step, divide by 2. Divide everything by 2. Divide everything by 2. Instead of dividing everything by 2, because that makes another fraction, I'm just going to multiply by 1/2. So 1/2 times what I already have. You can distribute the 1/2. You don't have to distribute the 1/2. It all depends. These questions are more likely going to be multiple choice, so you just go until you find one you like. If you were going to distribute it, you would distribute it to the fraction and to the 1. So if I distribute it to the fraction, I would distribute it to the bottom because the 2 is on the bottom. So you would multiply the 2 times both of these guys. So negative 4/3 plus 1/6. And then this guy would just become 1/2. Okay. But again, it's when you're doing these problems, you just go like this answer, I'm okay with. If you left this answer on a free response, I'd be okay with that. Y is by itself. But if it's a multiple choice, you just have to go until you find an answer that you like. Okay. That's where it gets crazy. This is where it gets crazy, not with the calculus. So many times in this class, we hear when it gets crazy, it's not because of the calculus, it's because of the math. It's because of the algebra. Algebra means solve for x. We're solving for y there, right? The crazy part is not this, because you've done this before. All we did was integrate. The only calculus, the steps for this, out of the 4 steps, step 2 is the only one we do calculus. Step 2 is the only one we do calculus. Step 1, you're just getting things on one side, that's algebra, math 1. Step 2 is calculus. Step 3, plug in a point, solve for C. Again, that's not calculus. That's not even math 2 or math 3. That's math 1 stuff. And then solving for y, again, same thing, okay? But so many times, I can tell you, step 2 is not the problem. It's always either step 1 you guys are pretty good at, but it's either step 3 or step 4, right? That's not calculus. So when you say calculus is hard, it's actually not calculus, right? Again, that's one of the reasons why the first thing you guys do is do the summer assignment quiz, because it covers all of those things. Because I know where students struggle. It's not with the calculus. It's with all of the prerequisite skills. Okay? All right, so here we go. Last one, and then I'll give you some time to work on your assignment. Okay? Here we go. What is the particular solution to the differential? So now we got a differential with a sine. So sine of x times y minus 3. So the angle is x, and then it's times y minus 3. Okay? Same steps. Everything with an x, get to the right. Everything with a y, get to the left. Multiply both sides by dx. I'm going to do it at the same time here. Save some time. Okay? So let's see. The y minus 3's cancel out from the right. The dx's cancel out from the left. We get 1 over y minus 3 equals 2 sine of x dx. That part you might be able to do in your head because you guys have been doing that so long. Okay, so step one, if you can do it in your head, do it in your head. That's part I don't really need to see the work. Okay. Okay, here we go. Integrate both sides. The x side, let's start with the x side. It's not that bad. It's just 2 times sine of x, right? The antiderivative will be 2 times the antiderivative of sine. What's the antiderivative of sine? Negative cosine, right? So we'll put a negative in front and then a plus c there. Good. The other side, we're going to have to use u substitution again. We're going to have to use u substitution for, let me highlight it this time, for this guy right here. Okay, I'm going to do it over here. 1 over y minus 3. Oops, forgot dy. dy. Okay. U is going to be y minus 3. Du will be 1 dy. Divide both sides. The 1 moves to the other side. Oops. Du equals dy. Okay. Put everything back in. 1 over u dy. Or not dy, du. So we can't change it to a power. We can't change 1 over x, 1 over u, because it's just u to the negative 1. But this relationship you guys have seen before. What's the antiderivative of this? Natural log. There you go. So we get natural log of u plus c. We put the bars around u because that always has to be positive. Always has to be positive. Put u back in. Y minus 3 plus c. I'm going to move that guy back in. Oops, no, we already have a plus c. We don't need a plus c there. Okay. Calculus is done. Okay. Plug in my values. 0 for x, negative 1 for y. Everywhere I see an x, plug in a 0. Everywhere you see a y, plug in a negative 1. Okay. So natural log negative 1 minus 3 negative 2 times cosine of 0 plus c. The natural log is going to be negative 4. That's why we have the bars. We can't have a natural log of negative 4. So it's actually just going to be natural log of 4. And then cosine of 0 is just 1, positive 1. So 2 times negative 2, or sorry, negative 2 times 1 is going to be negative 2. Add 2 to both sides. Natural log of 4, I can't use a calculator. Doesn't say anything about calculators. So natural log of 4 is a decimal. It's probably 1 point something. Leave it as natural log of 4. Just leave it as natural log of 4. Unless they say round your answer, which they didn't, we leave it like that. We leave it exact. Equal C. Okay. We're going to plug that in for C. We're going to plug that guy in for C. Okay. So, actually, what? Let me move this down further. So we have the natural log of y minus 3 equals negative 2 cosine of x plus the natural log of 4 plus 2. And we have to solve for y. Well, there's only one y. So you have to go back. We have to go back to math 3 here when we learned about natural logs. There's only one y here. All right, there's no other y's. I have to separate the log from the y. There's only one way to separate a log, to take away a log. So it involves changing log, natural log. Natural log is the same thing as log with a base of e. It's the same thing. Okay, that's the first step. What's the second step? Change it from a, right now it's in log form. How do I know it's in log form? Because it's got a log. I have to change it to an exponent form. Convert it to exponent form. Exponent form starts here, goes here, and then here. So it's going to be e to this power. So let me color code this. It's going to be e to this power equals this. That's how to get rid of a log. E, what's that?
So e to the negative 2 cosine of x plus.
Yeah, so this is going to be the power here.
Which would then equal y minus 3.
Which equals y minus 3, yeah. To solve it, we take away the bars, yeah. The only time we need the bars is when I'm plugging something in for y. I'm not plugging anything in for y. I'm done with that, right? So that's the only time I need the bars. Like there was the last group test. You had two, I think it was number 1. You had 2 options. One was with the bars and one was without the bars. The only time you need the bars is when you're plugging something in. If you're not plugging anything in, you don't need the bars. We're already done plugging in, right? We plugged in negative 1 for y. We already did that. So we don't need the bars technically anymore. Okay? And then the last step, solve for y by adding 3. E to the negative 2 cosine x plus natural log of 4 plus 2 plus 3 whole equals y. Sometimes, if they allow you to use a calculator, you'll have to break this up. See these pluses here? We could change it to this. Using the exponent rules. You could change it to that. The reason they would maybe have you do that is because this guy is a value. This guy is a value. This guy is a value. The only thing that's not a value, that's a variable, is this guy here. So if it was calculator, they would probably have you multiply these two guys together, add 3, and then do that. But like I said, most of the time it's a non-calculator. So without a calculator, this is as far as I can go. Okay, that's as far as I can go. Okay. The ones with a natural log are usually the craziest ones because you have to change them from a natural log to a exponential. And then, but you guys did it in Math 3, so it's not stuff you haven't done, it's just you haven't done it in a while. All right, so what I'm going to do is I'm going to give you the rest of the time to work on the assignment. I'm going to post the key right now, so you'll be able to check your answers as you go. If you want me to do any problems, I can.